A'udhu billahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. After studying the complete theory of chapter 3, no, in today's lecture, we are going to solve the exercise of third chapter exercise of financial market institution. The first question is write down the formula that is used to calculate the yield to maturity on a 20 years 10% coupon bond with 100 face value that sell for 2000. Student, remember that in this chapter 3, we we learned to define four type of trade instrument, among which number one is simple loan, fixed payment loan, coupon bond, and zero coupon bond. Not only we define these four types of trade instrument, but also solve the issues related to these instrument, and each of them have their own formulas, their own calculation. So this is coupon bond. So coupon bond formula, which I was given to you in previous lecture, is present value is equal to R 1 minus 1 divided by 1 plus I raised to power n whole divided by I plus future value divided by 1 plus I raised to power n. Or you can also use the formula given by the book, but I always prefer to use this simple formula instead of the complicated one given by the book. So according to the formula which I suggest you, the formula of this equation is present value is equal to R 1 minus 1 divided by 1 plus I raised to power n divided by I plus future value divided by 1 plus I raised to power n. Basically, this is the formula of this coupon bond. No, I am trying to put the values which are given in this equation question 1. So this coupon bond is selling for 2000. So present value of this bond will be 2000. PV mean present value is equal to R mean periodic payment, yearly payment. So periodic payment, student, remember that periodic payment will always be will always be calculated by using this formula. The formula is periodic payment is equal to coupon rate of a bond multiplied with face value of a bond. So coupon rate in this case 10%, face value 1000, periodic payment will be 100. Further, R 100, further 1 minus 1 divided by 1 plus I. I is not given in this case. I means yield to maturity or market interest rate, not a coupon bond rate. So I is not given, so I am not changing I. Raised to power n, n is given 20 years, and 20 divided by I not given, no change, plus future value of this bond. Future value or face value. Face value means the value of a bond. The value of a bond in this case is 1000. 1000 divided by 1 plus I raised to power 20. So this is the answer of question first. Now question 7. If there is a decline in interest rate, which would you rather be holding, long-term bonds or short-term bonds? Why? Remember that whenever you are certain about the prediction of interest rate, in this case the interest rate will be decreasing in future, so long-term bond will be more beneficial as compared to short-term bond, because we know that whenever the market interest rate is falling, the bond price will be increasing, and whenever the bond price in future will be increasing, it's mean your capital gain, there will be more capital gain as compared to short-term bonds. So you would rather be holding long-term bond because their price would increase more than the price of the short-term bond, giving them a higher return. Question 3. In this question, a financial advisor giving advice to a manager that short-term bond, long-term bonds are a great investment because their interest rate is over 20%. Is this financial advisor necessarily correct? If I compare question 2 and 3, in question 2, the future prediction about interest rate is given to you that the interest rate will be decreasing. But here, just a financial advisor just giving you an advice that long-term bond give more interest as compared to short-term bond. But in this case, about the market interest rate, you are unaware about the market interest rate. So this will be a more risky if in future the market interest rate increases. So there will be a more capital losses instead of capital gain. Whenever you are unaware about the market interest rate, the fluctuation about market interest rate, so in that case short term bond will be more preferable as compared to long term bond. Question 4: if mortgage rate rise from 5 to 10%, but the expected rate of increase in housing prices rises from 2 to 9%, are people more or less likely to buy houses? Mortgage rate means loan with some collateral. So simply, you you remember that mortgage means loan. So before changes, 5% loan, the housing loan is given at 5% rate by the bank, and the inflation in housing prices is 2% at that time. So the real interest rate will be 5 minus 2. Nominal rate minus inflation rate is equal to 3%. So in that case, the real interest rate was 3%. But after change in mortgage rate and inflation rate, the change mortgage rate is 10%, or loan rate is 10%, and the inflation rate is 9%. In that case, the real interest rate is 1%. So we are well aware about the distinction between whenever the real interest rate is at low. So borrowing will be more beneficial as compared to lending of a money. So in this case, people will be more likely to buy houses. Further, question 3, quantitative question. Calculate the present value of a 1000 zero coupon bond. As we know that this is a case of zero coupon bond, and zero coupon bond is similar to the simple loan case. So we are using the simple loan case formula, which is future value is equal to present value divided by 1 plus I raised to power n, or present value is equal to future value divided by 1 plus I raised to power n, which is here future value 1000, number of year 5 year, and interest rate 6. By using all these information, we can easily find out present value is equal to 747.25. Question 2. A lottery claims that their grand prize is 10 million. 10 million payable over 20 years at 5 lakh per year. If the first payment is made immediately, what is the worth of this prize? Or what is this grand prize really worth? Use an interest rate of 6%. So basically this question is to find the present value of this 10 million, which will be distributed in 20 years at 5 lakh per year. So this case is fixed payment case, because its maturity is given, periodic payment is given, interest rate is given. So this is fixed payment or amortization of loan case. And the fixed payment case formula is present value is equal to R 1 minus 1 divided by 1 plus I raised to power n divided by I. Here R is equal to periodic payment 5 lakh per year n. As first payment is made immediately, this means that the first payment of this lottery is also equal to the present value. Therefore, we are converting remaining 19 lotteries into present value by using above formula. In question, this is clearly say that the first payment is made immediately. So, immediately means today, and today means that amount is also equal to present value. So, first installment will be minus from the number of years. So, the remaining years will be 19. So n is equal to 19, I is equal to 6%. By putting these values in above formula, we can easily find out present value is equal to 5579058. This is the present value of 19 lotteries. And the first is made immediately. So I am adding 5 lakh in this present value. So the worth of 10 million over 20 years at the rate of 5 lakh per year will be 6079058. Again, I am repeating the question and its solution. There is a game of lottery which give 10 which will be distributed 10 million among the winner over 20 years at the rate of 5 lakh per year. But the first payment is made immediately and the market interest rate is 6%. So what is the worth of this 10 million lottery game? As we know that this is the fixed payment loan case formula, we are well aware about the formula, but the question arises about n is equal to 19. As the first payment is made immediately, so 5 lakh is I put 5 lakh aside, 5 lakh aside. So the remaining 19 lottery are the remaining 19 years amount. So I will try to convert the remaining 19 years amount into present value. R 5 lakh per year, n is equal to 19, I is equal to 6%. By using these three variable into above formula, we can easily find out present value is equal to 5579058. So this is the worth of 19 years, 19 years installment. So the question is to find out the worth of all 20 years 10 million. So I will add 5 lakh in it. The worth will be 6079058. Next question. Consider a bond with a 7% annual coupon and a face value of 1000. Complete the following table. Kindly see your book. Open your book. The table is given in your book in question 3. There are some information given and you are asking to fill the blanks which are there in the table. So this is coupon bond. So I am using the coupon bond formula, and here present value is equal to R 1 minus 1 divided by 1 plus I raised to power n divided by I plus future value 1 plus I raised to power n. If you see the table, so all blanks are the present values. So I am trying to find out one present value. The remaining present value will be try by yourself. So R mean periodic. Periodic payment in this case is 70. Coupon rate multiplied with J 70. Interest rate is given in table for first blanks. In this question, the common data are as under. Coupon periodic payment 70, face value or future value face value 1000, while additional data for first blank space is as under. For first, n is equal to 3 and I is equal to 5. N is equal to 3 and I is equal to 5. Now by putting all these data in above formula, we can easily get present value is equal to 1054.46, which is this is find out for this first row. In question, what are given to us? Coupon rate 70 and future value 1000, and the additional information is number of year 3 and interest rate is 5%. By using these four information in this formula, in this coupon bond formula, we can easily find out the value 10 4.46 for this first blank. This is first blank. So similarly, you can easily find out all these. Next, consider a coupon bond that has a 1000 par value. Par value means face value. Par value is the second name of face value. And a coupon rate of 10%. The bond is currently selling for 1150 and has 8 years to maturity. What is the bond yield to maturity? Solution. The case is again coupon bond. So I write the coupon bond formula, which is present value is equal to R 1 minus 1 divided by 1 plus I raised to power n divided by I plus future value divided by 1 plus I raised to power n. The data in this question is as under: periodic payment 100, future value 1000, present value 1150. As in question, the second row, the bond is currently selling for 1150. It means present value. Number of year 8, and to find I. In this case, to find I. Remember, whenever we are trying to find I, we are using the method of interpolation. What is interpolation? Interpolation is a method to find an unknown number between two values. Whenever a question is asking to find the interest rate of a coupon bond, so we will always be trying to use interpolation method. And interpolation is the method which by using that method we can easily find out an unknown number between two numbers. In this method, we will try two different interest rate. As we know that the present value of this bond is 1150. So we will be trying to find one interest rate which give present value below 1150 and the second interest rate which give above 1150. So we will trying to find two values for this two present value for this bond on the basis of some interest rate, some arbitrary interest rate, but these values must be lower than 1150. One value must be lower than 1150 and the second value must be greater than 1150. In this method, we are trying two different i's in such a way that one give the value present value below the given value which is 1150 and the other give above it. By using this way, we trying interpolation to find the actual I which gives the present value 1150. So first of all, I am trying I is equal to 5%. When I try I is equal to 5% in above formula, all remaining all values are with me. As we know that R is equal to 1000, future value R is equal to 100, future value 1000, number of year 8, and I am using I is equal to 5%. So this give me present value. This give me present value 1323.16, which is greater than 1150. So no, I am trying another interest rate which give less than 1150, which give me the present value of this bond less than 1150. As you know, there is an inverse relation between interest rate and bond price. So I will be trying when I intentionally falling the price of the bond from 13 to 3, so the interest rate will be increasing. So I use 10% interest rate. At 10% interest rate, the bond price is current bond price or present value of bond price will be 1000. So by using these information in this table, first of all, I write first interest rate. I take first interest rate 5%. At that 5%, the bond present value is 1323.16. And then I try the second interest rate, which give the name I3, 10%. At 10%, the present value of the bond is 1000. And between these two, 5% and 10%, the interest rate at which the present value will be 1150 is in between these two interest rates. So no, here we are applying the interpolation. Interpolation is, first of all, I am finding the difference between these two interest rate 1 and interest rate question mark, which is unknown, is equal to x. And then in second stage, the difference between interest rate 1 minus interest rate 3, which is 5% minus 10% is equal to minus 5%. Similarly, on right hand side, the difference between present value 1 minus present value 2 is equal to 173.16, and the difference between present value 1 minus present value 3 is equal to 323.16%. Then after that we are taking the values. This x will be divided by this difference. The first difference will be divided by the second difference as mentioned below. This is similarly here, the first difference will be divided by the second difference as given here. By rearranging, we can easily find out x is equal to minus 0.027. While we know that x is equal to I1 minus I question mark. No, putting all the values in this, we can easily find out I question mark is equal to 7.44%. So our desired rate of interest is 7.44%, at which the present value of the bond will be 1150. Again, I am repeating this question. Consider coupon bond case. Its face value, present value, coupon rate, number of year to maturity is given. The question is to find out the market interest rate or yield to maturity. The market interest rate or yield to maturity, for market interest rate or yield to maturity, we are using interpolation. And this is an interpolation. What is interpolation? We are trying to find out two interest rates, and we are trying from ourselves two interest rate. One giving the value of this bond greater than the value greater than the current value of given in the question, and the other interest rate giving less value as given in the question. So between these two interest rates, we are trying to find out the desired interest rate, and this method is called interpolation. Next, question number 5. You are willing to pay 15,625 no to purchase a perpetuity that will pay you and your heirs 1250 each year forever. As we know that perpetuity means forever. Starting at the end of this year, if your required rate of return does not change, how much you would be willing to pay if this were a 20-year annual payment ordinary annuity instead of perpetuity? So the question is have two parts. In first part, the question is giving you a suggestion that either you purchase a perpetuity or either you purchase a ordinary annuity. So as the return on this perpetuity is R is equal to 1250 divided by 15625 is equal to 8%. Now instead of this perpetuity, if in ordinary annuity with same 8% return and same annual payment 1250, the purchaser will be willing to purchase by using following formula. So this is the formula of ordinary annuity formula is similar to the fixed payment loan. Again, I am repeating the question. The question is asking, first, you want to purchase a perpetuity with a price of 15,625, and this perpetuity give you 1250 return. So the rate of return will be 1250 divided by actual. So the rate of return will be equal to 1250 divided by 15,625 is equal to 8%. Now the question is further asking, instead of purchasing this annuity, this perpetuity, if you are interested to buy a annuity of 20 years, so what will be your purchasing price for that annuity? As we know that interest rate 8% or 1250% n is equal to 20, then we get present value is equal to 12275.68. With the same rate of return, the rate or the present value of the perpetuity will be 12,272. Next question. Question 6. What is the price of the perpetuity that has a coupon of 50 per year and a yield of 2.5? As we know that price of a perpetuity is equal to coupon bond divided by interest rate, yeah, yield to maturity. So coupon bond periodic payment is 50 per year and market interest is 2.5%. So the bond price will be 2,000. If the yield double, what happened to the price? No. No, the yield becomes double, 2.5 to 5%. The bond price will be 1,000. I think this is enough for today. Thank you, students.